First of all, let me just tell you about the on-grid system, because as you guys all know about that, for solar plant, when we connect the solar module with your particular load, that means let's say you have a certain kind of residential load, or you are running in the industry. So when we are connect your solar plant with the inverter, and then you can connect it with the certain load, just as you can see here. So this is the solar, as solar irradiance come to the solar module, then it goes to a specific device called AGB or DCDB. So this is called DC distribution box, where the power flows first and then it comes to the inverter. Now this is basically the overview of on-grid solar plant. Now here this inverter is on-grid solar inverter. Now where on-grid stands for, like this inverter will particularly connect with a certain grid, and also there will be a solar input. Now here you can see this is the solar connection is coming to that particular inverter through that DCDB, which is called DC distribution box. And then that particular inverter will convert that solar energy, like solar energy always comes in a DC like direct current variant. So that's why you have to convert it through the inverter in alternating current, because in our specific normal requirement conventional way, we required always AC current. So that's why we need an inverter to convert that DC power in AC power. Now again a specific equipment required, ACDB, which is AC distribution box, and then it goes to the LT panel. Now here this LT panel is basically that when the power connection comes to everyone residential or everyone premises, then there is a certain distribution box over there from where each and every load is connected. So that is known as that LT panel, where the direct grid line is coming. So on that particular LT panel, we will connect that solar input, and then there will be a metering system called net meter, which actually give you that particular solar and specify the solar and grid. That means during the daytime, when your solar is powered, like generating the solar power, so it can directly goes to your load. And let's say in a specific condition, when you are your household load is as you can see, your household load is, let's say, 10 kilowatt. Okay, now during the daytime, let's say in this specific winter conditions, so during the daytime the electrical load in our normal residential houses are very less. So in this particular situation, if we just consider that your overall load of that particular house in a specific house is 5 kilowatt, okay, and you have installed a 10 kilowatt solar plant. Now in this situation, what will happen, that this net metering system will according to your requirement, the grid will separate your solar. That means when you require 10 kilowatt power and you have a 10 kilowatt solar plant, now your solar plant will give you, let's say, 5 kilowatt. So the extra 5 kilowatt will come from grid. So here that solar and grid will operate accordingly, according to your requirement. Now, if we talk about the off-grid system, so in the off-grid system, what will happen? So during that off-grid system, what generally happens, that's when the specific grid, as we already talk about that on-grid. So in this on-grid system, the inverter is a grid tie inverter or on-grid inverter, because there is a connection of grid. But in this off-grid system, what will happen, that specific inverter will become as a off-grid inverter. This inverter will work as a off-grid inverter. Okay, and there is no support of the grid. So here the big role plays by the battery. Okay, so specific difference of on-grid and off-grid is that support of the grid. So off-grid will generally applies for certain areas where the grid is not possible. Like you won't be able to connect the grid, like in rural areas or where the grid accessibility is not there. So in such situations, off-grid inverter is generally used. And if we talk about the pumping system, now in case of pumping system, what generally happens? Let me just show you a diagram. Okay. So in case of pumping system, what will happen that sometimes during the irrigation process, when solar module generally placed on the ground, like in the farmers like irrigation ground, and there is a certain options that we use solar modules as a power generator and use the pumping power source, and through that pumping system we can like use the irrigation, and we can just it is help us to grow different kind of crops and different situations. It also a kind of off-grid system. There is a no option for grid connection. Okay, so now I am just going to first of all tell you that what is the main role of this particular software. Now here in this specific software, we can design three type of systems. One is grid connected, that means that what I discussed, that grid tie or grid connected system. And another one is standalone. Standalone here means that off grid system, and pumping, of course, the pumping system. Now grid connected, specifically here, grid connected system is our focus. Here we are generally discussing on the grid connected, and then we will go to the overview of standalone and pumping. So now for the grid connected, we need to just know that why we require this software, and what is the basic purpose of this particular PVsyst software. So there are a few points we need to discuss here. So the first thing, when we are installing a solar plant, so there are specific reasons behind that. Now, big industries are installing in megawatt scale solar plant, and they are investing like huge amount for this particular project, different kind of projects. So what is the purpose, that why they are putting this much of money in this renewable field? So the main reason is that when we are talk about the net metering system or gross metering system, so it helps us to reduce our electric consumption and to like enhance us to use the free power, that means the renewable energy. And also there is a option of your money return back. That means, let's say you are investing 1 lakh rupees for a certain project. Okay, now after a certain period of time, according to the discom tariff, your money will return back after a certain year. That means, let's say before installing a solar plant, your electricity bill coming up almost you can just imagine, let's say I'm just considering it as a 10,000 rupees. Now after installing solar plant, your electricity bill has some kind of deduction of it coming around 6,000 rupees. Now this 4,000 is your savings, let's say yearly savings. So according to this, you will get a ROI, that is called return on investment. It applies with any kind of projects, any kind of like capital expenditure, where you are just putting your money, your investment. So how you are getting your money back from this particular investment. So this is called that ROI. So where the PVsyst plays a big role, because when I am just planning to install a plant, so I have to know that like after how many years or after how many time I will get my money back. So for that reason, we need the solar plant generation, because when I am putting a plant, I need to know that what will be the generation. According to that generation, I can estimate that after how many years that money will be coming back. So that's why PVsyst plays a very important role when we are calculating the ROI. Okay, return on investment or payback period. Now, there is another few points which is very important for why we are using PVsyst. The next point is that when we are designing a solar plant, so the most important part is string design, like how you are how you are connecting your solar modules with the inverter. So you need to make strings of solar modules. So now to make or to prepare these strings or to prepare the SLDs of any project, we need to know that perfect string. So that string calculation is very big or very tough mathematical calculation. So you need to just do permutation combinations and different kind of things with the strings. So here the PVsyst helps us that according to the temperature of that particular location, according to the different situation of that particular location, PVsyst will let us know and how what are the module and inverter you are choosing. According to that, PVsyst will let us know what will be the perfect string for a particular specific project. So this is the second benefit of PVsyst software, and that is very important when we are designing anything. And the third thing is that PVsyst take the meteorological data to gives us the generation, like the yearly generation or yearly generation data. So that meteorological data, when you are considering it, but there are some certain losses which are included in the plant generation. So that losses option is also available in this particular software. So that means when you are getting the final generation from this software, it is somehow nearby the realistic value. But there are few things we need to consider when we are talking about the generation, because it's a theoretical concept and we are just here considering everything. In the practical situation, it may differ, but there are some certain type of margin we need to consider when we are just considering the PVsyst generation. Okay, now I'm just trying to design a specific project, and how to just take the data. I'll just show you guys. Okay, so the first thing we need to just go to that grid connected system. Now here I have just done a specific system. So to create a new project, what we need to do, just go to that grid connect, and here new option is there. So just click on new. So when you just click on new, you will get this new project option. Now let's say I'm here going to show you guys. So this is a specific project what I have done previously. So here you can see this. This is the overall plant design what I have already done. So this thing is a specific building. In this building, we can place 247 modules, and that capacity according to the 330 watt peak module, it's coming 81.51 kilowatt. Now we are trying to design this particular system in this PVsyst software and check out the generation from this particular particular rooftop project. Okay, now here I am going to just name it as IT building. Now I give that project name. Now the next step is we need to create a site file. Site file here, to create a site file, that means we have to create a meteorological data, like we have to create a meteorological file or meteo file we can say. So for that, we have to just click on new site. When you just click on new site, it will just open up a geographical site parameters window. Now here, what we need to do, we have to just mention the specific location of that particular site. That means the latitude and longitude of that particular site. So here I have that. So now when I just specific latitude longitude, given that specific latitude longitude here in the locality, and click on search button, and you can see this, it automatically search that particular area. Now you have to do here this locality, country, latitude, longitude, altitude, all the thing will be there. Now you have to just click on accept selected. Now here it will give you the site name. So I am just giving it as same. And here you can find this latitude, longitude, altitude, time zone, all the details will be there. And there are different kind of databases is available. So there are different kind of database. These are meteorological database. That means the solar irradiance, wind speed, turbidity, humidity, different kind of weather related data will be available with these database. Now, I always recommend to choose that meteonorm 7. What will be the version? Like if you just using a older version of PVsyst, it can be like 7, meteonorm 7 or meteonorm 7.2. So it depends. Now here I am choosing this meteonorm 7.3. Now you need to just click on import. When you just click on import, it will take time to gather the data. Now you can see that after that import option, you will directly go to that monthly meteo option. So here this monthly meteo, you get this kind of data: global horizontal irradiance, diffuse irradiance, temperature, wind velocity, link turbidity, relative humidity. So these are the weather related data. Now here what you need to do, this is the monthly, like kilowatt hour per meter square per month basis data. But I generally used to when we generally analyze data, so always we used to consider kilowatt hour per meter square per day. Okay, so here you need to just choose this option. Just a minute. This option, this one, irradiance units, kilowatt hour per meter square per day. Now you can just click on OK and save it there. So after just when you just click on save, so it will create a synthetic data also. Okay, it's done. It's done. It will take time to reload all the data. Now a synthetic hourly meteo file has also been generated. Do you want to save it? So synthetic hourly meteo file is basically, here we are taking the data in a monthly basis. So the software will automatically do this synthetic hourly meteo workout. So they have just segregated those data in a hourly basis. So you can just click on yes and save it there. So after saving all those things, you will directly go to that particular project page. Now here software will tell you selected meteo file. This is the meteo file, and you need to save the project. So after that, you have to save your project. Now click on save, and here you have to save it. So when you have done with these things, now software will ask you orientation is not defined. So before going to the orientation, we need to go here project settings option, and few things we need to mentions here. Okay, so the first thing is that albedo. So albedo is a kind of thing like in which kind of surface you are putting your solar module. So albedo is that dependent upon that surface. So albedo is a kind of dependent upon the surface, which kind of surface you are putting your solar modules. Okay, according to that you have to just mention here data. these are the like different kind of options for the albedo, which is your surface grass, fresh grass. So this thing is generally important uh, for specifically bifacial modules, because for the bifacial modules, you guys know about that both the sides are covered with the cells. So according to your surface, how the solar irradiance is reflected from the back side of that surface, so bifacial module work accordingly. For the normal modules, albedo is not as such an important like factor. Now we need to go to that design conditions. So here in the design conditions, in this specific temperature sections, you have to mention your like the temperature, lowest temperature of that particular location, highest temperature of that particular location, and the average temperature of that particular areas. So these details you can get from a specific different kind of websites are there, so you can get it from there. Okay, so let's say I'm just here roughly considering it as 10 degree, and all other things are remaining same. Okay, and nothing much you need to change here. You have to just select this thing, mu VOC. Mu VOC is specifically the temperature coefficient value of VOC. This value is generally we required from specification. We need to choose it here. Other limitations will be remain same. Preferences here, preferences is mean that like if you are choosing a specific latitude longitude for to gather the data, so if that if the database don't have that particular location data, so the database will search around nearby that particular location, that 10-kilometer radius area. So that's why it's mentioned here 10 kilometer. Now, in a certain case, you won't be able to find the data, like your you put that latitude longitude and the software is won't be able to find the data. So in that case, what you need to do is you have to just maximize this range. Like you have to just put it here, instead of 10 kilometer, you have to put it here 20 kilometers. So it depends according to the data availability. So after just changing all those data in the project settings part, now you again you have to save your project. Now you can go to the orientation part. Now before going to the orientation, I need to tell you here that regarding this variant. So what does it variant means? Variant meaning that PVsyst gives us a very very useful feature, which is, let's say you have a certain capacity plant. Let's say you are planning to install a 100 kilowatt plant. Now you want to just check the generation with different kind of module and inverter. That means, let's say I want to check my plant generation with a local branded module and local branded inverter, and also I want to check that with a high quality module and inverter, what is the generation difference. So in such cases, the variant will very much helpful for us. Let's say here I am giving a name that I am just using here Vikram 330 watt peak module and Delta 50 kilowatt inverter. So the 50 or 60 kilowatt, what depends. It's a 50 kilowatt inverter. Okay, so I can just mention it here, right? Now let's come to the orientation part. Now here in this orientation, there are different kind of fields, all like different kind of options is available. When we are just installing a structure with fixed structure, that means there is no movement in the structure, there is no certain seasonal adjustment is there. So it's a just fixed structure. So in that case, we need to choose fixed tilt plane. Now in this fixed tilt plane, we have to mention here the tilt angle. Now the point is how to decide the tilt angle. To decide the tilt angle, here you have to go to this particular section, loss with respect to optimum, this particular percentage. Now here you can see it's minus 0.2% with the 30-degree tilt angle. Now if I just decrease it here, Now you can see that it's coming 0%. So now when I just going 24, it becomes again minus. So here you can see with the 25-degree, the loss percentage is become 0, and the global on collector plane, that means this particular irradiance collection is become maximum 2031 kilowatt hour per meter square. So this is called this specific tilt angle for which the loss with respect to optimum becomes 0. This specific tilt angle known as optimum tilt angle for that particular plant. Okay, now click on OK. So when you just done with the orientation, now here one thing I need to tell you, that azimuth angle. So azimuth angle, it depends according to your building orientation. Like if you are putting your module in the true south direction, so your azimuth will be 0. Now if is there any deflection with the true south, so that will be the azimuth angle. Like if you are putting your module with a certain kind of deflection, there is a certain kind of angle is there, so that will be the azimuth angle. If you are just moving your module in towards the west direction, then the azimuth value will be positive. Let's say I am putting here as a 5-degree, so you can see that this section option will be just moving towards the west direction. Now if I just mention it as -5, then it will become as just going towards the east direction. So it depends how you are putting your modules. So I am considering here the azimuth as 0°. Now click on OK. Now we need to go to the system part, which is the very important and the most important part here I need to like consider. So let's say I have chosen that 330 watt peak module. So let's say I'm considering this one, 330 watt peak, and delta okay, delta 50 kilowatt module. Now according to that drawing what I have shown you guys, that this particular project having 81.51 kilowatt capacity. So first of all, here in this case you can see pre-sizing help, this option. So here what we need to do, we have to mention your estimated capacity. Like if you have already done that drawing, you have that details that yeah, this will be the capacity, so you can just mention it here. That is 81.51, but I have just checked it out. Okay, you can mention it. Now like in many cases what I have like understand from people, that most of the designer do here, they have mentioned the overall area, like available area here. So that is a very wrong practice. Here this area what software like considering, that will be the like module area. It's not the available area you have. Like let's say you have 1,000 square meter area in your rooftop, and you have like put in here, like put it here, your 1,000 square meter. Then software will estimate your plant capacity in a very wrong way, because let's say you have a roof, but every roof having some kind of obstacles. Like there might be exhaust, there might be water tanks, there might be a mumpty, like what you can see here. These are the water tank available here, these are the mumpties. Due to this mumpty there will be a shadow. So as you all know guys, that shadow can affect the module, right? Shadow can like degrade your module, and there is a like big chance of certain emergency conditions. So that's why we always try to place your solar module like in the shadow free areas. So that's why always try to do the design before going to the PVsyst, or just draw it in a SketchUp or AutoCAD, and then estimate it what will be the capacity, then put it here. Okay, so I am putting here as a 81.5 kilowatt capacity. Now I have chosen the Vikram Solar, and this is the specific brand, and this is the inverter. So here different brand name is available. So if you want to, let's say, instead of Vikram you want to choose Vari, so where you press W it will come up Vari. So I'm just want to Vikram Solar. No, it's okay. Let's consider it as a higher options. Let's say 340 Eldora model. Okay, 340 watt peak model. Now here you can see there is an option called number of MPPT inputs. Now here software considered automatically 3 MPPT. Now, to know about these things in detail, it requires too much time. So I'm briefing you on the MPPT part. Every solar on-grid inverter, specific on-grid string inverter, because in the solar inverter section there are basically two types of inverter. One is string inverter, one is central inverter. So when you are using a string inverter, as you can see, it's a string inverter, 50 kilowatt string inverter. So when you are using a string inverter, so in that case, there will be a two section of the inverter that is known as MPPT. That means MPPT signifies that maximum power point tracker, which is generally divided the inverter in specific sections to maximize the plant power and as well as to give you a flexibility in the string sizing. Now, what does it mean? It means that when you have a specific plant, let's say specific, you are working on a specific design. So in that case, when you are just choosing the string, you find that there are certain 18, like with the 18 modules some strings and with 19 modules some strings. So if you connect that 18 modules with the 19 modules in a single MPPT, then what will happen? That 19 modules string will become as a 18 modules string. So that is why MPPT plays a vital role for plant design, that when you are just connecting your strings, you have to segregate your string numbering according to the MPPT, because let's say I have a 18 module strings and I have also 19 module strings. So in that case, what I will try to put that 18 module string in a single MPPT and that 19 module string in a separate MPPT. So that this is the basic concept where MPPT stands for. Sorry guys. Okay, now here we have a 81 kilowatt plant capacity, right? So let's say I am trying to use here 50 kilowatt 150 kilowatt inverter, and the one is 30 kilowatt inverter. Okay, so for that reason I am just here, I need to just I am just deselect this use multi MPPT feature, and I am just choosing here as one inverter for 50 kilowatt. For 50 kilowatt, I am just choosing one inverter. Now here you can see the software will suggesting you 27 to 20 modules maximum you can connect in a string. 20 modules, up to 20 modules in a single string you can connect. So I'm choosing here as 20 modules in a series. And number of strings, according to 50 kilowatt, I am choosing here number of strings. Let's say it's 8. So according to that 8, it becomes 54.4 kilowatt. Okay, or yeah, 54.4 kilowatt. Now what I need to do, that means 54 kilowatt is there. Now I can just increase it here little bit as 20 into 10. So you can see this is the error box. This is we call error box. Okay. If is there any kind of, when you are designing or choosing the strings, if you are doing anything wrong, this error box will let you know that what you are doing wrong. The array maximum power is greater than the specified inverter maximum allowed input power. That means this inverter having the maximum power you can input in this particular inverter, which is 63 kilowatt. Okay, so here your capacity has become 68 kilowatt. So what I will do, I will try to just consider it as 9. Now you can see it works fine. So it becomes 61.2 kilowatt. Okay, 61.2 kilowatt is completed here. Now, what is the left capacity? 81.5 minus 61.2. It's 20.3 kilowatt left. So in this case, this 20.3 kilowatt, I will try to create a sub array. This sub array required when you are planning to use 2 inverter or multiple inverters. In that case, you have to use the sub array. Now, how to use this sub array? So here list of sub array option is there. So this is your first sub array. Now I am just here add a subarray. When you click on this particular option, it will create a subarray. Now I have added a subarray. Now here I am going to choose a 20 kilowatt inverter, and here I am going to mention it as 20.3. Okay, so here you can see again I am just putting a 1 inverter and 20 into 3, 20 module in series and 3 number of strings are there. So it becomes 20.4. It's nearby same. Now you can just check out the overall plant capacity, what you are designing here. Your number of modules becomes 240. Your PV power capacity has 81.6. Maximum PV power is 80 kilowatt and nominal AC power is 70 kilowatt because we have considered 50 kilowatt inverter and 20 kilowatt inverter. That means total AC capacity is 70 kilowatt and your total DC capacity is 81.6 kilowatt. Now, why this DC is high and AC is low? So this is basically called overloading, and this is happened because solar plant never generate its maximum capacity. Like 81.6 kilowatt never generate 81 kilowatt. Okay, so it will always like generate nearby 60 kilowatt. So that's why we can just, there is a certain limitation is there, 25%. So according to the DC capacity and AC capacity, you can decrease it 25%. Okay, so that is why we are just we have just considered the AC inverter capacity as 70 kilowatt. Okay. Now, when you are done with this specific designing section, you can just click on OK. And then there are specific options are there. The very important part, what I already told you guys, that detail losses portion. So here, this detail losses comes into the picture because when you are just trying to estimate the yearly generation, so we need to consider the which type of losses can happen in a specific plant. Now there are specific different sections available. You can see thermal parameter, ohmic losses. There are lots of losses are there. So thermal parameter, as usual, the name suggests that what are the thermal or temperature effect can impact to the solar module. This is basically the thermal parameter. So in this case, there are specific few options available. Default value according to mounting means in which way you are putting your modules in the plant. Let's say I am putting my plant in a ground mounted area. That means there is no options of any external temperature or evacuations. Like when you are putting your plant in a rooftop. So in the rooftops, sometimes what happens that AC ventilators or any chimney is there, so it can like raise the temperature of your module. So in that case, that is a different factor for a thermal point of view. So for free mounted modules with air circulation, this you need to consider this one for ground mounted projects, or anywhere you are putting your plant where there is a no temperature exhaustion, or there is no like exhaust which can increase the temperature of the module. So in that case, you can choose the free mounted modules. Now, semi-integrated with air duct behind. Now, this one you need to consider. Let's say you are putting a plant in a rooftop and there is some kind of AC ventilators is there, or you are just installing modules in a industrial shade where ventilators available. So in that case, you have to just mention it as semi-integrated with air duct behind. And the last one is that integration with fully insulated bag. This thing is applicable for if you are just putting your modules in the shade, according to the shade. So shade, how the shade is there, and you are just placing the modules just above on the shade. So in that case, there is a no option of the module to like cooling down during the daytime. So that in that case, you have to consider it as integration with fully insulated bag. Now, ohmic losses, as the name suggests, it implies that if you connecting your cables, like when we are just connecting our solar inverter with the load, and from the solar module to our load, how the power flow is going. So during that power flow, which type of cables you are using, so there are certain kind of loss can happen. So this is called ohmic loss, because due to the resistance, these losses happening. So that is why you need to consider these losses. So the first section is that DC loss, where the basic standard value is default 1.5%, and the voltage drop across diode. That means to restrict that shadow impact on solar module, there are certain kind of diode which are generally connect with solar module, that is called bypass diode. So in each and every module, this bypass diode is available. So due to this diode, there are certain kind of voltage drop can happen during the generation. So that is here 0.7 volt generally considered according to the PVsyst default value. Now there is AC losses is available. So for this AC loss, you need to consider that your cable size and that specific loss fraction percentage should be accordingly maintained in such a way that your loss fraction value should not be increased up to, like, there is a certain limitation up to 2%. You can't go beyond that. Okay, so let's say in that case, what you can do is, like, let's say from the inverter to your connection point where you are going to evacuate that power, so there is a distance of 60 meter. So I am just putting that 60 meter over here. Okay, now here that loss fraction has become 2.55%. That means it crosses 2%. So in that case, what you need to do, you need to just choose it here as 70%. That means the square mm size. That means in that case, you have to increase your cable size. Okay, it's in copper, you can see. Now, if you are planning to use an aluminum cable, then you can just choose it here as aluminum, and you can see that for the aluminum, you have to increase the size. Now, for aluminum, I've chosen, let's say, for 95, it becomes 2.24. So we need to choose it here 120 square mm. So according to this, you can just consider it. So for copper, I'm coming to copper, and I'm just trying to choose it as 70 square mm. So it's 1.82%. Okay. Now going to that module quality LID mismatch. So these are the very specific parameters which are related to solar module, and these details generally you can consider these details as a default value. As module efficiency loss, you can just choose that default one. LID loss factor, light induced degradation. This is generally happens when solar module first time like exposed to the sunlight. So there is a certain kind of degradation happen to the module. So that is here 2%. This is a default value. And module mismatch losses. This is what I already told you guys, that if you just connect your different strings in a single MPPT, then there will be some certain amount of losses. So that is called module mismatch losses. But here's, and also there are few reasons where the module mismatch losses can happen. That is why some default value is there. So you need to just choose the default options here. Now come to that soiling loss. Now, what is this soiling loss? So soiling loss basically, as the name suggests, that it generally happens due to that dust layer which can comes over the module. Like if you are just not cleaning up your modules for a long period of time, so there is a certain dust layer can come over the module. So it restrict the solar radiation to come to the solar module. So there are certain kind of losses can happen. Now here the default percentage is 3%. Now I'm telling you that percentage is 3% is somehow high. Now it depends that where you are putting your plant and how frequently you are planning to you are planning to cleaning your modules. Like if you are just cleaning your modules weekly basis, then you can just consider this loss as 2%. Now, there is no option for cleaning or the module is the area is very much dusty, or like if you are just putting your plant in a cement industry, so they have the huge amount of aerosols are there. So it can the losses in that case is very high. So according to the situation, you have to consider the losses. IAM loss, incidence angle modifier. So this loss is basically happened due to the glass layer of the module. Like when the solar radiation comes to the solar module, so due to that glass, there is a certain kind of deflection on the irradiance. So that is known as IAM losses. It depends on different glass type. That means here you can see Fresnel normal glass. Like if you are using normal glass, then it automatically takes the data from the module data. And auxiliaries option is available for big level plant. Like if you are just installing a megawatt scale plant, so in the megawatt scale plant, that control room power requirement and all the external power which is required to control the plant or maintenance or to monitor the plant, so those specific power generally take from the solar plant itself. So these are the auxiliary details what you can define here. Now the next option is called aging. So aging is specifically that after, as we all know that solar module having a lifespan of 25 years. Now 25 years, during this 25 years lifespan, so from the first year to 25 year, there will be a certain kind of degradation in each and every year. So according to that degradation, there will be certain losses can come up in every year. So when we are talking about that first year generation or second year generation, then after that certain generation losses will be there because of the module degradation. Now if you want to use this aging factor here, so you can just click it here as uses in simulation. Now when you just click it here, you can just check out the losses percentage. Let's say I want to know after 25 years how much module can degrade, what will be the degradation loss. So in that case, what we do, you just mention it as 25 number of years here, and you will get to know that use in simulation loss is 15%. Okay, after 25 years, there will be a loss of 15%. So this is the losses portion. Now, generally, when we are giving the report to any kind of clients who want to know that first year or yearly generation, so in that case, we generally don't consider the aging factor. Or if you want to use the aging factor, you have to just select it that year number of 1. Okay, and then the option is called unavailability. Now what is it? Unavailability specifically used, like the term basically signifies here as that when we are just installing a solar plant, so grid connection is very important for the plant operation, because that on-grid inverter will not run if is there any kind of power cut. That means if your grid is not there, your inverter will not your inverter will not operate. So in this situation, you have to consider some unavailability. So unavailability means here, if you have any kind of power cut, or if is there any bad weather condition when the plant can't operate, or is there any maintenance schedule that, yeah, after a certain period of time there is certain maintenance required in different sections. Like if you are just investing in a big level plant, if you're talking about a big level plant or a 50 kilowatt, 80 kilowatt, 100 kilowatt plant, so there might be some issues can come up after 1 year or after a few months. So for that reason, you have to consider some unavailability factor, during which time or in a specific year or yearly span, how many days the solar plant can't operate. So that is here mentioned as, let's say I am considering it as 2%. So this is the default value 2%. You can choose that. And you can see that the unavailability duration is 7.3 days per year. So I'm just, if I just increase the number of periods, so here you can specifically see the different specific date when the power cut can happen. So you can just choose it here, or you can just set random. Okay, and then you can come up with the spectral correction. Now this spectral correction, it depends on that when the solar radiation comes to solar module, so it travels a lot from that sun to solar module. So it has to cross the different mediums. So when that crosses the mediums, so there are certain kind of spectral losses happen on the solar radiation. So it depends on the specific technology wise. So if you just use spectral correction in simulation, so there will be automatically it will take data from that module specific data. Now here the losses part is over. Now I am clicking on OK. Now specifically here, one thing I need to tell you, just I forget that, which is here that you can see that Vikram Solar, Delta, these are the datas. Now point is, let's say you have a specific brand, let's say Wiry. Now Wiry launching a new module of 380 watt peak. Now how would you get that 380 watt peak in this particular software? So to get that, there you have to collect a type of data is known as PAN file. For module, the PVsyst compatible file is PAN file, and for inverter, the PVsyst compatible file is OND file. So these files you need to collect it from the manufacturer itself. If you just ask to the manufacturer regarding this PAN or OND file, they will give you. So according to that PAN and OND file, you can just easily import it from. I'll show you guys how to import it. So import it and you can get it in the system part. Now after detailed losses, there will be certain options: self-consumption and storage. These options is specifically required if is there any storage system available. So when you are talking about grid type, so there generally we don't have any storage available. So that's why I'm just leaving it here. And horizon and near shading, these are some pro level options, which is I won't be able to discuss here. But just know that this is specifically the drawing sections where you can just draw your rooftop and you can just place the modules. Okay, so this is a some type of like critical job, so I can't show you here, but it's known as the shading scene construction, or you can just place the modules and you can according to the shadow what kind of losses can happen, the PVsyst can tell you. Okay, so this is that near shading options. Now module layout, if you draw anything on the near shading, then you can get it out from the module layout. So module layout basically stands for string layout. Like if we talk about in the solar plant. So how the strings is connected. So there certain kind of layout is generally used for plant installations, during the plant installations. So module layout is somehow related to near shading. Like if you draw near shading, then you can draw module layout. Now energy management. So this energy management is specifically, there are lots of details are there. So generally inverter temperature, it depends that how you are like placing your inverter, like in which location. Is there any certain temperature maintain, like you have maintained any temperature, or you are using in a outdoor installation, so you have to just click it here, outdoor installation. And then coming to power factor. Now for solar inverter, generally the power factor value is 1. So unity power factor, solar inverter generally operates in unity power factor. So there you no need to change anything here. Then grid power limitation, it's specifically not applicable for net metering system. So this option is generally not required for net metering systems. And then P50 and P90 estimations. So this is basic, like very important part from my point of view, because when we are just getting the generation data from this particular software, so this is specifically a probability value. Like PVsyst take the historical meteo data and gives us the certain output that, yeah, if you choose this inverter and this module, and you will get a, like this will be the generation, like it will show you a generation. Now how trustworthy this generation data? So that is why PVsyst gives us a opportunity to take the probabilistic value. It means here I am going to choose it here as monthly averages and mention the climate change generally 0.5%. Annual variability, just consider the default value, and just let it be the simulation parameters and uncertainties. These values are generally default value. You can choose it here. Now here P75 value we can take. Now what does this P75, P90 or P95 stands for? These values basically stands that when the software running that simulation, so software give you a probabilistic value with the 90 times, that means software runs the specific simulation, and 90 times the value comes above this P90. So I'm just coming this P90 after running the simulation, it will be then clear. Now I'm clicking on OK and run the simulation. So when you run the simulation, this kind of simulation process will go. Okay, so now this is your PVsyst report. This is the new format, basically PVsyst new version. It's they have updated it. So here it will be the project name, your variant name, shading sheen is not there, no shading is there, system power, and what is your specific site, IT workshop billing, what I have just given there. Now this is the project title, what is the project title and variant, it will be there. And here you can see the details of your geographical site, what will be the albedo, what is the altitude, what is the meteo data you have considered. And here the grid connected system simulation for year number 1. Like I have chosen the year number 1, that is why it is year number 1. Now if you want to know that after 10 years what will be the generation, you can just choose that year number 10. Now fixed tilt plane, here tilt angle and azimuth angle, these are the tilt and azimuth. Number of modules, we have chosen 240 number of modules. The PNOM total stands for your solar plant capacity, 81.6 kilowatt. That means your solar plant capacity. Number of units, sorry. Number of units, it means that your number of inverters, here this is the inverter details, what is the number of inverters? So two number of inverters. PNOM total, this is the AC capacity, like 70 kilowatt, because according to that designing 50 kilowatt and 20 kilowatt. And PNOM ratio stands for your DC and AC ratio. So here that DC ratio is, if we just go for the DC AC ratio, 81.6 divided by 70, so it becomes 1.16. So 1.16 here. Now produced energy. This produced energy is your final output details, that for the first year with this 81 kilowatt plant you can get 121.9 megawatt hour generation. That means this is your produced energy for this specific plant. And there is an option called specific production. So what does it, this specific production means? Specific production means your, according to your overall generation, how much energy you are generating in per kilowatt peak basis. That means I'm just giving you the calculation here. Let's say it's 121.9 megawatt hour. So 121.9 into 1000. This is your kilowatt hour units, and divided by 81.6. So it is become 1493.4. That means according to the per kilowatt peak basis, how much energy you are getting from this plant. That is known as specific yield or specific production. This one. This is called specific yield or specific production. And then comes up the performance ratio. It defines the solar plant performance, and this is basically the ratio of how much actual generation the solar plant is generating and how much generation it should be, like what would be the actual generation and practically how it's generating. So the ratio of this both is known as that performance ratio. So here these general details will be available, that for the specific, for the 50 kilowatt inverter, 340 watt peak modules, I have considered 180 number of modules, and how the string is 20 module in series, 9 strings available. And according to, again, for the 20 kilowatt inverter, I have to use 60 modules, 20 module in series, 3 strings are there. And then the array losses parts comes into the picture, where you can get the loss factor, mismatch loss. That means what are the losses you have considered in the detail losses tab. Those losses will be here in this report. DC wiring loss, system losses, unavailability losses, AC wiring loss. So these losses will be available here. And now if we just come to the generation, like main results page. So this is the main results, where overall produced energy, this will be the overall produced energy. And here it will be specific production and performance ratio, as I already told you. And this is the, according to the meteo data, how the generation is happening. Now here you can see, this is the E array megawatt hour. So E array basically stands for the generation from the solar, solar DC side. That means before the inverter. Before the inverter, how much generation is happening. After the conversion of that particular from the inverter, so it is going to that E grid. E grid means that how much energy you are totally connected to the grid, or how much energy actually you are getting. Or otherwise, if you find difficulty to understand this terminology, there is each and everything is mentioned here. Global horizontal irradiance, ambient temperature, global inclined in collector plane, global effective, E array. So E array is the effective energy at the output of the array. That means in the DC side. And E grid means that energy injected into grid, and PR stands for performance ratio. Now comes to the loss diagram. So it's very important because how the losses is happening and how you are finally getting your generation. So before going to the loss diagram, I want to just take some questions here, then we'll again continue. If you guys till now, guys, if you guys having questions, so one by one, please ask questions. No one having any questions? Okay. No one having questions, so let me go through this. So here, when we are talking about the loss diagram, so first thing, this 1865 kilowatt hour per meter square. So this is the actual irradiance which is coming to the solar module. And how much is effective, we are going to know that. So 1865 is that horizontal irradiance, like you can just check it out here. This is the global horizontal irradiance here, kilowatt hour per meter square, global horizontal irradiance, 1865. So here it is 1865 kilowatt hour per meter square. Now you can see global horizontal irradiance or global incident in collector plane. Here there is a plus sign. So in the loss diagram, if anything on plus sign, it means it stands for some kind of gain. That means you are gaining your energy. So here 1865 kilowatt hour per meter square to there is a gain of 8.4% because of the tilt angle. Because when you are just putting your solar module, you are giving some kind of tilt angle to it to get the like maximum generation. So for that tilt angle, you are getting here the plus. That means plus 8.4%. Then there will be a certain amount of losses, that IM losses because of the glass. As I told you, there will be a losses. So that is IM loss, and then soiling loss factor, what I have considered 2%. So it is here 2%. Okay. And after the losses, after this gain and after the losses, you can find that 1931 is your final output, like the effective solar radiation which is coming to the solar cell. Okay. Now here this 466 meter square collector plane. This means that your solar cell area, overall solar cell area. That means if you are using a specific module, so overall solar module, number of modules, if you just multiply your overall solar number modules and then your specific module area. Now let me just explain this thing. Here you can get it. Okay, in the new report it's not mentioned. So specifically, let's say I am here I have chosen 240 modules. So for the 240 modules, this is 466 meter square is your is your module module dimension, overall cell dimension, not module, overall cell dimension. Now the point is, when the solar cell convert the solar radiation in electrical energy into electrical energy, so it converts according to the solar module efficiency or solar cell efficiency. So the efficiency at STC is 17.54. So according to the efficiency, when the solar radiation converts to electrical energy, so the energy becomes 157.7 megawatt hour. So this is your like up after the conversion, solar radiation to solar conversion, you are getting this much of energy. Now there will be a loss of module degradation. That means these losses are basically related to the solar module up to this point. Just up to this point, like before the inverter, what are the losses is happening? Module degradation, PV loss due to irradiance level. That means if like during the morning time, the solar irradiance is very less. So during that period of time, generally the solar plant is won't be able to operate or won't be able to start. So there will be a certain loss for that reason. PV loss due to temperature, that is the most important part or most important factor we can say, which plays a very vital role for the temperature. So if the temperature varies like different weather conditions, according to the weather condition, temperature varies. So according to the temperature, there will be a certain loss. So this loss is 14.77%. And then spectral correction, module quality loss. So these are the losses which can happen. And this portion or this section is basically the inverter losses. So generally in the inverter, there is only efficiency losses there. You can see the inverter loss during operation or efficiency. So this is the efficiency losses there. And after that, there will be a AC loss. AC loss means during the like after when the power is coming up to the inverter, then from the inverter that power is going to like evacuation point. So there will be a cable connection, that is AC cable. We know that. So that AC cable losses is here 0.67 and 2.1% for the system unavailability. So these are the specific losses which relates, and from this 157.7 megawatt hour, it becomes as 121.9 megawatt hour. So this 30 megawatt nearby, like 36 megawatt hour is your overall loss. Okay. So yeah. So this is basically the specific report, and this is the input output diagram. It basically stands for according to the different or like different irradiance and how the solar generation is happening. So according, let's say for the like different plane, the collector plane, how much radiation is coming. So according to this, these points indicates the overall generation. And this one is the power injection according to the your generation, how the power is injecting to the grid. So this is the diagram for that. And the final one is that P50 and P75 and P90. So here you can see that P50 value, which is 122.5 megawatt hour, and that P75 value is somehow less and P90 is the lowest one. So what does it mean? It means that when PVsyst is running this simulation, 90 times the simulation results cross this 114.11 megawatt. That means 90 times means 90 times is coming above this value. Okay, that means this is the maximum probability. Now here is 75. That means 75 times the generation value crosses this 118 megawatt. And P50, which is the lowest probability, where the generation coming 1.20.55. That means 50 times the generation crosses this 120.5 megawatt. So here, if I consider this value, that means there are certain limitations are there. That means this might not be accurate. But when I am using this 75, that means I have a margin, and it somehow give me a kind of accurate generation. So that is why this probability options are available with the software. You choose the specific percentage that which one is used for your generation directly, because for different kind of plants we need to give the client as a guarantee that this will be the generation directly for a specific plant. I will give you this much of solar generation. So in that case, if you will completely at that generation, you have to pay some penalty to the client. So that is why we need to always stay on a very safe side for this kind of generation commitment. Okay, so that is why I say I recommend for generation commitment. Otherwise, if you want like have a line for any specific project, so in that case, that can just it totally depends on the business model and how you are teaching your client. Okay, so this is overall the grid price system explanation. And if you guys till now you guys have any questions, please ask me. I think no one is unmuting their mics. Yeah. You guys can come to chat box also. Or if anyone is having a problem with the language, you can ask me in Hindi as well. No issue. You can ask me in any language, no issue. No question. यादव किसी का कोई भी क्वेश्चन नहीं है चलो कोई बात नहीं क्वेश्चन नहीं है तो हम आगे बढ़ते हैं Indranath, please ask some question. You are here. Indranath, Molik. How calculate Azimuth? Okay, so good question. So to calculate Azimuth angle, there are specific processes. Few software are there, also you can just check it out. In a design. So I was giving you that tool. This is called Room Azimuth tool. Okay. This is same thing on solid metric. So okay, Azimuth tool. This is not working. Yeah. So Room Azimuth really and then here you have placed your laptop. We just find out over here. This is not the right one. Okay. For which So to find the Azimuth angle, this is a tool called Room Azimuth tool. You can just place that location where you want to install the plant. And then let's say this is a building. Okay, these are the all south building. Let me just give you another building where some kind of idea. So let's say this is the building. Okay. So in this building, as you can see, this building is not in the true south direction. Where if I just check this building or these buildings, these are all under the true south direction. Okay. True south means it's oriented in this building oriented in totally true south. What we can see in the specific map. The front side, that is the lower side of your building, is the south direction, and the back side is north, and this is east, and this is west. I mean, again, that this is the north, this is south, this is east, and this is west. Okay. Now. These colors, as you can see, totally oriented in the north-south plane, in the total true south direction. Now, if I have any building which is having like some kind of deflection, let's say this building. So this building has some angle, it's not oriented in the south orientation. Now, if you place your solar module in south, like according to the true south. Then it's known as in that case you no need to place it as Azimuth anywhere because you are working on solar modules into south. Okay. Now if I place these modules according to the building, then in that case you have mentioned the Azimuth. Now here if I want to know the Azimuth, so what I have to do? I have to choose the Azimuth tool. And according to the building, just building orientation, I will choose a line. So this is the line. So here you can see I have given a line. So here what is coming? 79.4. This was 169.44 to 59.4. So what you do is you have just minus 90 minus 79.14. So here we are Azimuth angle is 8.66 degree. Okay, so you have to just place the line according to the building, how the building is oriented, and then how the angle is coming. Now let's say I'm just giving it as a true south. Is a straight line. So you can see this is the 90 degree line. This is the south direction, and when the building is in such a way, so when the line just starting radius starting angle, so there will be a starting deflection of that line. So that is known as the Azimuth. But this is roof Azimuth, not the solar plant Azimuth. Solar plant as Azimuth, when you consider solar plant as Azimuth, when you are working on solar module according to the building. Just example. As you can see, this building not into south direction. There is a certain deflection. Okay. So I have placed the modules according to the building. So that means in this case, my solar plant has an angle of 5 degree southeast because the building is oriented in the southeast direction. So that is why that is mentioned here as south 5 degree south. In the same way, here my building is into south and my module is into south. So it is the Azimuth angle will be 0. Okay. So this is the concept. It's clear. Anyone having any questions? Sir, how to get peak sun hours in any exact application? Peak sun hours. Okay. Peak sun hours, to get peak sun hours, we have to understand the sun path diagram. Okay, just a minute. To get the peak sun path, here the specific horizon line are there. Now it's a kind of like tough job to give the explanation for this. But to get the peak sun hours, what will be the maximum for a particular area? So you have to understand this horizon drawing. So it's somehow a little bit of tough. But I have some explanation. You. I will guys give you that time. Don't worry. I just take up this video. I will just show you our YouTube channel and all the details. Okay. So you can get details from there. And another question is coming that how is the string according to MPPT. So this is a very typical job. And to do that, you have just no specific technical data, technical knowledge of solar. Means when you are connecting your strings to inverter, so you have first of all check that how many MPPTs is available at the inverter and what is the number of input you can connect in each MPPT. So know that you have to just click on that specific inverter. So here is the specific inverter, and here I am just spinning that file. And here additional parameters. You will find two options. One is multi-MPPT capability, and the other is string inverter. So here this is true means you are not having two MPPT, and number of string units is 12. So each MPPT having 6 number of inputs available. That means in each MPPT you can connect 6 number of strings. So according to this process, you have to decide your string and connect it using here wisely. Because here the number of you have just it as multi-MPPT and given the multi-MPPT, let's say 2 MPPT. So 2 MPPT and 9 strings I want to distribute through the 2 MPPT. And the same way, if I just go to the sub-array 2, here you can see if I just use 2 MPPT, there I have just divided that 3 strings into MPPT. Okay. So here you can also find the MPPT chapter. Here 2 MPPT available and number of inputs are 4. So in such a way we can do that. And let's say in this specific load inverter, I want to add 19 strings and 18 strings because I have 4 MPPT. So 19 strings and 18 strings. So for that in that case, what I need to do, I am having 1 MPPT here and giving here 19 and 2 strings. Again, I am creating a sub-array. Just add a sub-array. Then again a sub-array is added. And here I am giving it as 18 into 2. Now in the first case, there are some errors. So I can't choose 19, but I choose 18. Yeah, 18 is okay. So 18 into 2 here and another sub-array. That means another MPPT I want to choose 17. So in that case, what happens that 2 MPPT I have given 17 module in a string for last 2 MPPT and for the first 2 MPPT. For the first 1 MPPT, I have given 18 series and 2 strings. So by the combination of 2 MPPT, there will be a 1 inverter. You can see here I have used
one MPPT, and here sub-battery has in 1 MPPT. So 1 and 1, it becomes overall 1 inverter, because 20 kilowatt inverter having 2 MPPT. So this is the concept, and it takes time to understand this logic. And if you just practice these things, it will be very easy. Okay. Now any other questions? I'll just take another question, and then I'll go to the next part. Okay, no one having questions, so I'm just going to the next part, which is basically the off-grid systems. So here in the off-grid systems, this is the on-grid we have done with the on-grid. And now standalone, going to the standalone part. So in the standalone system, all the basic criteria like project creation, video non data collection, all the things will be same, project safety, everything will be same. So the main difference is that the inverter can have to mention your user needs. User need means that for the off-grid system, we generally use off-grid where the grid is not available, and we want to run some load through the solar energy. Okay. Some questions. So we want to run the system. To like energize my specific load or specific, let's say you have a TV or tree or lamps, anything is there. So for that reason, you have to mention your loads, your wattage of your load, that is, let's say LED lamp, so 18 watt LED, and daily use 4 hourly distribution. Now there will be an hourly distribution option. So what does it hourly distribution means? So hourly distribution here, it means that let's say you want to run your LED bulb during the night time. During the daytime there is no requirement. So what is the hour during your after, as they have mentioned that this is the demo version. So the demo they have mentioned, you can see from the 7 hours to 11 hours they have mentioned. Okay, 7 hours to 11 hours. This is the marking of the hours. For the TV, PC or mobile, they have marked this as 3 hours, which is from 3 hours to 21 hours. That means 3 p.m. to 9. So this is the way how you have to distribute your hourly your load hourly consumption. Okay, and you can just specify these things according to the seasons as well. Like here you can see this is for the summer. Again for autumn, winter, spring, for different seasons you can mention the different load distributions and load details. So according to the details, you can find out the daily total required energy, and here the monthly energy requirement. So this is your energy requirement, and this energy should be fulfilled by solar and battery. Okay, this is your energy requirement, and this energy requirement should be fulfilled by solar or battery. Now, this is the specific consumption. When consumption details, you have to go with the system. So here in the system part, you have to just mention choose the, as usual, the wattage, what is the module you want to use, and what is this controller. Now here is the trick is like, in this case, you won't be able to use off-grid inverter because PVsyst don't have that kind of off-grid inverter. So here you have to use the specific controller according to your voltage and charge controller rating. Okay. So basically for the off-grid system, what happens? in between the module and inverter. Just a minute. There is no maybe in the theory. Okay. So this is a simplified case where you can see this is a PV array and it is coming to a regulator. This regulator is basically the charge controller or off-grid inverter or hybrid inverter. Basically, we call it charge controller. Now, this charge controller basically works as a protecting device. Means that it generally connects your solar module, batteries, and just as here you can see that backup generator is available. So these things are connected to the regulator, and this regulator give that power or distribute that power to your specific load or the users. As you can see, this is the PV array power on here. This is the regulator collecting the power. Again, generator collecting the power. Again, battery collecting the power. Now, here battery takes power from regulator and also gives power to the regulator. It means that during the daytime, like if we just consider the rural area system. So for the rural areas, what happens? People doesn't require electricity during daytime. They generally require electricity during the night hours. So for the night hours, they require let's say they given an LED or they want to just watch TV or run a fan. So these loads can be run through the battery. So during the night hours, the electricity will be given by the battery. And during the daytime, what will happen? As there is no load during the daytime, so the battery will charge through the solar. So here regulator is kind of a junction from where the power flow is controlling. So that is why we call it as charge controller, which is controlling the power flow of that overall system. Okay. And this is the simplified process. So here, first of all, if we just want to choose the storage system, so there is a long calculation process. So you have to just select your battery, which is your battery you want to use for your specific project. There are different kind of technologies and batteries are available. So you have to choose that battery here. And then you have to just mention your temperature, operating temperature of the battery. What is someone is giving chat? Okay, just leave it. Okay, so this is the battery capacity, and now here what will happen? We have to just fulfill the energy requirement throughout the battery. Means that, let's say, according to the voltage and battery capacity, you can get the detailed idea of your overall energy requirement, which is PVsyst generally suggests you to do that. Here, if you just click on this two default button, it will automatically choose the how many number of batteries required and what would be the age and global capacity. Right now, in the new collector array, you have to choose the solar module and which module you want to use, and then there will be controller. So there are different kind of charge controller available in the market. So you can see that direct coupling, PVT converter, DC to DC converter, different options are available. So which one you want to use, you have to choose here. Then backup means that if you have instead of beyond one battery, if you have a specified DG, that means which can give you the power during the night or in emergency situations. So you can just mention that DG details, like what is your DG, is which DG you have, and what are the details of the particular DG. So this is all about the specific details of the users for off-grid system, and we just run the simulations. So so you can get the report as well. So here in this case, as we already discussed that different parameters like how to consider the strings, all those stuff. So these details will remain same. The only thing will change here. Here the user speed will come as according to the details you have mentioned here. Summer, autumn, winter, different seasons, how you have distributed the loads. So according to that, the generation like energy requirement details will come up. And then they will find this main results page where you can just find out the available energy, used energy. Then this is the available energy. This is the used energy. Available energy means according to the solar production. This is the overall year. This will be the available energy. And from that, this is the actual used energy. And this is the unused energy. 3.99 unit per year is the unused energy. And this is not because of that during that daytime you don't have that much load, so that is why there is some kind of energy you won't be able to use. Okay, so that is the unused energy. Specific production, as I already told you, our performance ratio, it will be remain same. And solar fraction, this is basically the solar according to the solar and the battery. What is the conversion ratio? That means how the solar is using for the battery charging and discharging process. Battery aging. So how the battery aging is happening, lifetime is 16 years. And finally, you will get a specific report. So here, you no need to just check it out here. So you have to just check this one. Sorry, this one. Solar fraction ratio. So that solar fraction ratio percentage is 0.99. This percentage should be like nearby 1. 0.9, 0.8, up to 0.8 is okay, but not less than that. So this is basically the used energy. Load and use. That means how much load is you have and how much you use. Okay, so what is your requirement and actually how the requirement is fulfilled through this system. So that is the basic ratio of that. Okay, and that should be above 0.88 with the data option. And the loss diagram will be remaining same. So the main difference will come from here. This portion when the battery section is come up. So according to the battery, this is the direct use percentage and this is the stored percentage. How much energy is stored and how much energy is directly goes to the grid. Goes to the load. And this 9% is the missing energy because of the unavailability of the load. You won't be able to use that energy. So this is overall the cost diagram of grid system. And if we just try to get an overview on pumping as well. So the pumping system will somehow relate the thing in such a way like the grid system, but here instead of specific load details, here you have to mention your water requirement. What is your overall water requirement of the year? As you can see, 5 meter per day. That means 5 liter per day your water requirement. Whole year your depth variation. That means what is the specific depth where you want to place your pump. Okay, so this is all the hydraulic pump concept. Here you can see this is concept. This is the ground level, and here the pump can be hanged, and throughout the pumping system you can just pull up the water and store it anywhere where you want to store. Okay, and here you have to mention some details of that static level, specific drawdown, and these details are somehow related to the solar pumping system. So, and here you have to mention the water requirement, and then the system thing will come up. So here what you have to choose, you have to choose the module, and you have to choose first the pump, which pump is required for your specific requirement. Okay, and the pump, according to the pump, here you have to use a direct coupling or the controller, because when we are talking about the solar pumping system, so solar pumping always using we have to use the controller, because according to the controller will control your pump according to the solar generation. Because when we talk about the solar pumping pump system, so pump always requires a certain kind of continuous current or continuous power. So that is why solar is like when you are talking about solar pumping, so solar is not generating the continuous power. It's totally dependent upon the solar radiation. So that is why we require a controller to maintain the pump operation. Okay. And here, if you just check out the report, so it takes time. Just trying to show you just a minute. So this is the basic overall summary of the report. And here all the details will remain same, but the main difference is the water details. Here you can see water pump specific water details, like how much water you are just pulling in per kilowatt capacity, what is the water need, and what is the water pump. So according to this, you will finally get the result here, which is water pump, water used, and water missed. So how much water you have used and how much water you have, like the pump has pump. So according to this, you can get an idea. If you miss lots of water, that means your design is having some kind of problem. Okay. And the detail losses are almost like loss item will remain almost same. Some pumping efficiency and pumping details will be coming up in the last portion. Okay, so that's all regarding the training. Now regarding this workshop, now I just want to tell you guys that those who have just getting few interest in this specific field, in this solar field, so I am offering a training on this PVsyst software, covering all the technical points and all the details regarding solar plant. So this is the syllabus. Everyone can get this syllabus. Okay. So here each and every details I am going to explain in this specific training program, which is already started that training program. But if you guys anyone want to join this training, so then I can just conduct another session for you guys. So this training is covering total 16 number of sessions. Okay, and it's covering all the technical parameters related to solar plant, and also how to consider those parameters in PVsyst software. So this is basically a advanced level training on PVsyst software. And also, if you guys want to know more about the solar, more about the solar technology, you can just check out my YouTube channel. Also, I have a YouTube channel. I'm just showing you guys my YouTube channel. So this is my old channel. Due to some AdSense issue, I have already locked this channel. But in this channel, you can find lot of PVsyst videos and solar industry videos. And another channel I have,
I have just uploaded one video there. So if you guys support me there, so I can just give some like try to make some like important video on that particular section. Just a minute. This one. So sorry, just delete that. So this is the another channel. So here you can just get some new details because I have just closed my old channel. So this is the new channel. Here also you can get some knowledgeable content as well. And regarding the training, if you guys anyone want to do the training, you can just connect with Vishwarup as well as you can just connect with me. I will just save you my send you guys my mail ID here. I'm just giving you here. This is my mail ID, and this is my WhatsApp number. If anyone want to know details about the training and anything about the solar related training, you can just yeah. Also contact Furenergy Grid regarding this training program, and also we are planning to conduct more training or more workshops on this kind of software. So, Vishwarup just you can take it from here. Yeah, please write that name.